This problem is another interesting problem. It is about motion of a tennis serve. It is basically about the game of tennis. We will read the problem and then see over here. Venus Williams has one of the fastest serves in women's tennis. Suppose that she hits a serve from a height of 10 feet at an initial speed of 120 miles per hour and at an angle 7 degree below the horizontal. The serve is in if the ball clears a 3 feet high net, that is 39 feet away, and hits the ground in the front of the service line 30 feet away. Determine whether the serve is in or not. So now what they have done is they have told some basic details of what the server over here, in this case Venus Williams, she is one of the most famous women tennis player. So she is serving, and over here they have given all the basic details of the serve, and we must see whether the serve will be in or out. So now this is the court over here. This is the net. It is 3 feet, and then it must go above it. If it touches this, it's a foul. It's not a proper serve. It will be, and also if it falls outside the service line, it is not a proper serve. So it must be falling inside. Now they have told the speed, everything, and whether when she hits over here, whether it will reach within this or no. That is what we need to find. Okay. So the court over here is 39 feet, but the service line is 60 feet. It is similar to what we have done before. We need to start with, okay, we need to start with the acceleration, velocity, position, the same thing. But over here, there is one important thing. This dash means feet. This is feet, 10 feet. You can see 60 feet, 39 feet. But then we have 120 miles per hour. So we have to convert to the same units. You can't keep different units. Now it is better to convert this miles to feet. Why? Because you can see so many things are in feet. Now it is better to convert this miles per hour to feet per second. So what we do is we convert this to feet per second. How do we do that? Now, if you're getting confused with this formula of conversion, it's very simple. If you have checked before, what is miles to feet? Now, miles to feet, if you have 1 mile, how many feet is it? It is 5,280 feet. If you have checked it online, or if you have just checked it, it'll be about 5.3 thousand feet. Okay, 5,300 feet. That's what we generalize. Exactly, it is 5280 feet, 1 meter in terms of feet. Now, what about the hours to seconds? Hours, how many seconds it is? 1 hour is 3000 seconds, 3600 seconds, sorry. So now over here, miles per hour, that means miles divided by hour. Now you need to convert this to feet per second. So what happens is miles to feet is multiply 5280 up, but this hour is down, hour to second, divide 3600. Basically, you're multiplying over here to hours. So that is how we get feet per second. So basically, you should just remember 120 miles is up, so 5280 divided by hours 3600 is down. And this theta is very important as well. Look, the person over here is hitting from like this. See, from top to down. It is going downwards from the horizontal dimension. That means this angle over here is 7 degree, yes, but downwards that is minus 7 degree. That is another crucial thing. And the initial height, where is the initial height? It is 10 feet. You can see over here, the serve is from the height 10 feet. So H naught is 10 feet. All this initial speed converted, theta is degrees and height. Now what do? We need to start solving. Now start with the vertical component. Always we do the vertical component and then we go to the horizontal. So now over here, vertical component of velocity and position function. Okay, this is another important thing. We have 9.8 meter per second square. This you need to memorize it. It will be 32 feet per second square. Okay, when you convert meter to feet over here, it is always See, this is miles per feet. Don't get confused. Now over here we are from meter to feet. It is 32 feet per second. So instead of 9.8, just remember it is 32. Then it's negative because it acts downwards. Now acceleration integrated to get velocity, it will be minus 32t. Okay. Now don't forget the constant. Why? Because it will change. Over here we have initial velocity and all, right? So now y dash of 0, we have done this in the last problem. It's the same thing. The same thing will be now repeated. What do we do? Y dash of 0 is V naught sine theta. The angle is -7 and the V naught is 176. Just put it in your calculator. But it should not be in radians. It should be in degree. You can clear your calculator. Shift 93 equal AC. Now we will put 176, sorry, 176 multiplied by sine -7. That is the answer. That is minus for 21.45 feet per second. Negative, okay? Because it's going acting downwards. Now, over here, that is the C value. Now, what about the velocity function? Over here, instead of C, put this minus. All you have to do is minus 32t minus 21.45. Okay, that is the initial velocity component. Now, sorry, that is the velocity component at time t. We have done the same thing before, but we use 9.8, just that we are over here using the feet per second square. Now, next would be position, right? Let's do the position. What is y dash of t? Integrate the previous just now velocity function. Integrate this. Over here, it will be minus 32t square by 2 or minus 16t square and minus 21.45t plus c. Now it is not 0. C is not 0. In the last sometimes it will be 0. Why? Because initial height is always starting from 0. But here they have told, right? Initial height is how much? 10. Y of 0. H naught. Y of 0. Initial height 10. So here this C value will be 10. If you put over here T is 0, 0 and this will be 10. So C value is 10. That's how we get this. Okay, now we found out the height equation. This is all about horizontal component. Sorry, vertical component. I'm sorry. See, guys, just remember. One second, let me go back. See, this is all vertical component. Okay. Now, let us do the horizontal component. Same thing, but horizontal component, we know the acceleration is 0. Now, integrate this. How much will you get? It is 0 plus c. So, we don't write 0. 0t plus c will be 0 plus c or just c. Now, over here, initial velocity component. We have done this in the last problem. Same thing. X dash of 0 will be v naught cos theta. Okay. Now, x dash of 0 equals 176. Why? We had found out when we converted this 120 miles per hour, it will be 176 cos minus 7. Put this in calculator, you will get the answer. We had already done for sine, just change it to cos. Now 174.69, 688, that is 69. That is initial velocity. Okay, now what next? We have to find the that is already found, sorry. That is over here. Why x dash of t is equal to 176.69? Because this just equal to c, right? So whatever is the constant of acceleration or the initial velocity component, that is it. That is the at x dash of t as well. So next, what happens is position by integrating the above. When you integrate this 174.69, you will have to multiply by t. Now over here, write the cases for the serve to be in. Okay, this much is over. Now we found out the vertical component position and velocity, horizontal component velocity and position. What next? We need to find these criteria, whether the serve is in or out. All we found out is very important to apply over here now. That is basic. Now over here, let us see the cases for the serve to be in, because when a tennis player shoots, the serve must be inside. If it's out, it must be redone. So from the figure, the ball to clear the net, what they have told, must have the distance over here greater than 3 feet at when? when the distance is over here, horizontal distance is 39 feet, what is the vertical distance? 3 feet. It must be more than 3 feet. Why? Because if it is less than 3 feet, if it's 2.9, it will fall inside, right? It must be more. So how do we do it? So over here, from the figure, to the ball to clear the net, vertical position, that is y dash of x, must be greater than or equal to 3, when the horizontal position is 30, exactly equal to 39. And what is the next condition? Next condition, when it lands, landing means what is the position, the vertical position? When it is landing, the vertical position is 0. It touches the ground, right? So over here they are told 3 feet. Yes, it's coming like this at 3 feet. Okay, the distance is 39. Fine. Landing means it is 0. Y is equal to 0. So this y of 0 is equal to 0. Sorry, let me go back. Y of 0 will be 0. And what must be the x value? X must be less than or equal to 60. This is the condition. Now let us solve for it. We will see one by one. The case 1. All you need to do is substitute in the position this thing equation. X of t is equal to 174.69t. We found out, right? Over here, just substitute x of t is equal to what? 639. So now solve for time t. What is the time t? T is 0.223 seconds. That means, let us see, at the time t, what is the y of t value? This y of t value must be more than 3. So all you need to do is substitute this time t over here, and what do you get? Everywhere, wherever t is, they put 0.223 everywhere. All you need to do is solve. You will get the answer 4.42 feet. Is this greater than 3? Absolutely. So the first case is good. The case 1, yes. So what we did is, the distance we know must be 39 feet. So we find the time at that feet. What is the time when it reaches this horizontal distance? It is 0.22 seconds. Now substitute this in the horizontal vertical component of position. So at 0.22, the height is 4.42. It is greater than 3. Fine. Now, what is the next? Yes, the clear enough to clear the net. Fine. But what is the next thing? When the ball lands, that means y of t is equal to 0. The distance must be less than 60. So let's find the time when the ball lands. How do we do it? Make this equal to 0 and put it in mode 53 calculator. You will get time. Take only the positive time, that is 0.37 seconds it requires when it touches the ground. So substitute this time in the horizontal distance. Over here, when you substitute this time 0.37, what is the answer? You're getting 64.6 feet. That means it is not less than 30. It is greater than 30 by 4.6. So if this is the service line, just go out over here. By little it is outside. So basically, it is not enough. See, the ball is uh, not high enough. No, it is, yeah, it is not, it lands away from the service line. So basically, see over here, the serve lands beyond the service line, so it does not clear the service. Okay, so whenever she hits in that height, it will go above the net, yes, but it will fall outside the service line. So no, the serve is out. It's not in, it is outside. So one of the condition is not met in the case 2, so it is out. So this is how we can solve this problem.